In this video, I will explain why H2O is a polar molecule. So to understand this one, you need to understand how the bonds are formed between the atoms. So if you look at the oxygen, we have got 6 valence electrons in the oxygen. Valence electrons means the electrons that are in the outer shell of oxygen. So 6 valence electrons in oxygen. So when it makes the bond with two hydrogens, what happens is that two oxygens are shared with each hydrogen. So if you have this oxygen atom, then so out of 6 valence electrons, 2 electrons are used to make the bond with hydrogen. So out of 6, 2 are gone. So how many are remaining now? So 4 valence electrons are remaining. So in the H2O molecule, there are 2 lone pairs of electrons on this oxygen atom. So what they do is that they push these bonds towards each other. And that's why the shape of this particular H2O molecule looks like this. Now, next thing is very interesting. Since oxygen is more electronegative, as you can see, there are more electrons on the oxygen, right? It is more electronegative than hydrogen. So the dipole moment is created and it is shown like this. So you can see that there are two dipole moments, one each between one of these bonds. So this is the first dipole moment, this is the second dipole moment. And if you look at the entire or the whole molecule, the net dipole moment will be like this in opposite direction. So this will be the net dipole moment. And you can see that it is not equal to 0. So when the dipole moment is not equal to 0, the net dipole moment is not equal to 0, then that molecule is called as polar molecule. So if you compare this with the CO2, CO2 is a non-polar molecule. The reason being, this is a linear molecule, okay? What it means is that even though there is lone pairs on this oxygen atom, the dipole moment between carbon and oxygen is shown like this. So you can see that these dipole moments are equal in opposite direction. That's why mu is equal to 0 in this case. And that's why it is non-polar molecule. And also look at the shape. It is a linear shape. Okay. Over here we have got this angle right between two bonds. And that's why the net dipole moment is not equal to 0. Thanks for watching.